Here is another problem on computing the mean, variance, and standard deviation of a discrete probability distribution. Let us have this problem. The number of classmates who are K-pop fans along with its corresponding probabilities is given in a table. Compute the mean and the standard deviation of the probability distribution. Here is the given probability distribution table. We have two columns. The first column, x, which refers to the possible values of our random variable, which is the number of K-pop fans. And the second column are its corresponding probabilities. If you notice, there is a missing probability in this distribution table. Let us always remember that the sum of all these probabilities should be equal to 1. In other words, if this occurs that 1 or 2 or 1 probability is unknown, let us just add all the given probabilities and subtract the sum from 1 to get the unknown probability. Let us have 0.27 plus 0.25 plus 0.18 plus 0.15 is equal to 0.85, and 1 minus 0.85 is equal to 0.15. Thus, we now found the missing value of the probability in our distribution table. This time, let us proceed to the process to calculate the mean and variance and standard deviation. We have the formula here to solve for the mean. Mean is denoted by mu, and it is determined by finding the summation of the product of the sum of the products of the possible value at its corresponding probability, while the variance is denoted by lowercase letter sigma squared equals the difference between here the sum of the products of the squares of the possible value at its corresponding probability and the square of the mean, while the standard deviation is simply the square root of the variance. Let us proceed to solve this problem. The first column, again, are the possible values. The second column are the corresponding probabilities. Let us add another column here, and we will denote is as the product of the possible value and its corresponding probability. We have 12 times 0.27 is equal to 3.24. 13 times 0.25 is equal to 3.25. 14 times 0.18 is equal to 2.52. While 15 times 0.15 is equal to 2.25. And 16 times 0.15 is equal to 2.40. We now have the products of the possible value and its corresponding probability. Next is, we determine the squares. We add another column and determine the squares of our possible values. We have x squared, and we have 12 times 12 or 12 squared is 144. 13 squared is 169. 14 squared is 196. 15 squared is 225. And 16 squared is equal to 256. After this, we need to add another column in our table, and we label it as the product of the squares of each possible value and its corresponding probability. Okay, there you go. We have x squared, the square of the possible value, multiplied by its corresponding probability. We have 12 times 100, no, we have 144 times 0.27, and that is equal to 38.88. Next is 169 times 0.25 is equal to 42.25. Next is 0.18 times 196, and we have 35.28. 225 times 0.15 is equal to 33.75. And lastly, we have 256 times 0.15 is equal to 38.40 or 4. Now that we have these values, we can now proceed to determining the mean and the variance and the standard deviation. Let us first have the mean. Again, the mean is denoted by the summation of the products of the possible value and its corresponding probability. Now, in this case, in other words, we have to add these to get the mean. We have 3.24 plus 3.25 plus 2.52 plus 2.25 plus 2.40 is equal to 3. It's 13.66. That is now the mean of our probability distribution. Next is we find the variance. In computing the variance, we need to determine the sum of this column, of these values here. That is 38.88 plus 42.25 plus 35.28 plus 33.75 plus 38.40. And the sum will be substituted in this formula, which is equal to 188.56. That is the summation of the squares, the summation of the products of the squares of each possible value and its corresponding probability. That is 188.56 minus the square of the mean. The mean is 13.66 squared. Okay, let me adjust this one. There you go. And 188.56 minus 13.66 squared is equal to 186.5956. Okay. And we have 188.56 minus 186.5956 is equal to 1.964 in 3 decimal places. This is now the value of our variance. Let us highlight the value of our mean. Now, to determine the standard deviation, we simply get the square root of our variance. Our variance is 1.964, and we input it here, the square root of 1.964, which is equal to, the standard deviation now is 1.401. We have calculated the value of the mean, the variance, and the standard deviation. Thank you.